In this century, it's likely that we'll detect signals from an extraterrestrial civilization. To explore the universe beyond our solar system, NASA launched the Voyager 1 probe into space in 1977, unaware that their small spacecraft would go on to achieve one of the most remarkable feats in human space travel. This achievement would forever mark an era in collective imagination and inspire future generations. Voyager 1's discoveries have broadened our understanding of the farthest reaches of the solar system and continue to provide new insights into the cosmos. The probe's ongoing journey embodies humanity's curiosity and desire to explore the unknown. Recently, however, Voyager 1 had a strange encounter with an unidentified space object, leaving physicists puzzled. Who or what has Voyager 1 contacted, and how long will it stay in orbit? Let's find out. In 1977, a Titan I Centaur rocket carrying Voyager 1 launched from Cape Canaveral, Florida, with a mission to photograph planetary moons and study Jupiter and Saturn, including Saturn's Titan satellite, magnetic fields, and rings. But Voyager 1 accomplished much more than this. Roughly the size of a small vehicle, the spacecraft was equipped with state-of-the-art scientific instruments of the time, including cameras, spectrometers, and plasma detectors to gather data about the planets it encountered. Voyager 1 began its journey and traveled for 2.5 years to reach Jupiter, where on March 5, 1979, it made its first major discovery, continuing to photograph the gas giant until April. Soon after, Voyager 2 followed suit, and both probes made numerous discoveries about Jupiter and its moons. Among the most surprising findings was the presence of sulfur volcanoes on Io, a feature never seen from Earth or by Pioneer 10 or 11. Voyager 1 also confirmed that Jupiter's 4 largest moons, Io, Europa, Ganymede, and Callisto, were part of a complex system. Additionally, the probe discovered Jupiter's powerful magnetic fields and radiation belts, which posed a hazard to any spacecraft flying too close. After completing its Jupiter mission, Voyager 1 headed towards Saturn, making its closest approach on November 12, 1980, just 75,000 miles from the planet. Voyager 1 discovered Saturn had far more moons and hundreds of rings, each composed of countless small particles. Its moon, Titan, was found to have an atmosphere, making it unique in the solar system. Voyager 1 eventually left the solar system in 2012, becoming the first human-made object to enter interstellar space, over 13 billion miles from Earth. It continues to send data to researchers, revealing valuable details about the structure of the cosmos. Scientists initially expected Voyager's entry into interstellar space to be gradual and uneventful, but the region proved more complex than anticipated. The solar wind, a plasma of charged particles that moves at supersonic speeds from the Sun, was assumed to gradually meet the interstellar medium, which contains particles from supernovae. These high-energy particles, known as galactic cosmic rays, are largely blocked by the solar wind from entering the solar system. The galaxy's magnetic field is thought to be significantly angled relative to the Sun's. Voyager 1 reached the edge of the solar wind in 2003, indicated by detectors showing subsonic particle movement. Around a year ago, the solar wind suddenly dropped by a factor of 1,000, becoming nearly invisible. Concurrently, galactic cosmic rays increased, matching expectations of being beyond the solar wind. Caltech physicist Ed Stone, Voyager's project scientist, noted this suggested the spacecraft had almost left the Sun's influence. Yet galactic cosmic rays appeared from one main direction, and no major changes in magnetic fields were detected, although the galaxy's magnetic field is angled by 60 degrees to the Sun's. Additionally, Voyager detected a weak, continuous plasma hum in interstellar space, a light rain. Sound scientists liken to rain. Since 2012, Voyager has been measuring the surrounding plasma as it moves further from the Sun. Despite the typically calm interstellar medium, Voyager occasionally detects shockwaves from the solar wind. As it ages, Voyager faces technical issues, including a recent glitch with its attitude control system, which keeps its antennae pointed toward Earth. The probe started transmitting incorrect data due to an old computer reactivating, but engineers have since resolved the issue. Some scientists wonder if it might soon be time to retire the aging spacecraft. Although it continues to function unexpectedly well, a mix of technological success and luck. Ralph McNutt, a space scientist, notes that unexpected problems are inevitable given its longevity. Looking forward, McNutt's proposal for an interstellar probe could launch between 2036 and 2042, potentially using Jupiter's gravity to travel deep into space and surpass Voyager as the most distant man-made object. Unlike Voyager, this probe could last 50 years. However, its mission proposal remains preliminary, as NASA's Decadal Survey Committee will review and decide in the coming years. Why do we need such probes when we have powerful telescopes like the James Webb Space Telescope? The simple answer is that each serves unique purposes. While JWST and the Roman Space Telescope study exoplanets and galaxies, probes like Voyager explore the Sun's influence in space. Together, these technologies complement each other, providing a comprehensive view of the cosmos. Voyager, though likely to fade in the near future, has led many scientists to prepare for its inevitable silence. When it stops transmitting, the engraved golden records on Voyager 1 and 2 will endure as timeless artifacts in interstellar space. According to Nick Oberg, a doctoral student at the Kapteyn Astronomical Institute, these records may eventually encounter stars, hinting at a future where Voyager's journey might still bridge the unknown realms of our galaxy. The Voyager spacecraft, carrying the golden records, an invention by renowned astronomer Carl Sagan, are imprinted with music and images symbolizing Earth and humanity, intended for any intelligent beings the spacecraft might encounter on their lengthy journeys. To calculate the likelihood of the golden records surviving these journeys and remaining readable, Oberg and his colleague tracked Voyager's forward paths and examined the spacecraft's surroundings. Their findings go beyond the probable extinction of humanity, the collision of the Milky Way with Andromeda, and even the destruction of most stars. This ambitious study was inspired by the European Space Agency's Gaia satellite, which maps over 1 billion stars with high precision. Initially, Oberg and his co-author aimed to use the newly released Gaia star catalog to predict which stars the Voyagers may nearly approach. By retracing Voyager's past and predicting its future course, they found that the Voyagers won't leave the solar system for another 20,000 years, when they pass through the Oort cloud, the shell of comets and frozen debris orbiting the Sun. At that point, other stars' gravitational pulls will begin to outweigh the Sun's. In about 30,000 years, Voyager 1 is expected to pass near the red dwarf star Ross 248. However, it's more accurate to say Ross 248 will pass near the motionless Voyager. Both the solar system and Voyager will have completed a full orbit around the Milky Way in 500 million years, a time comparable to the formation and breakup of supercontinents like Pangaea. During its galactic orbit, Voyager 1 will oscillate above and below the galaxy's main disk, spending time in less star-dense areas. This variation in its vertical motion affects the survival chances of its golden record. Protected by an aluminum case and an etched copper disc underneath, the golden records were made to potentially last 1 billion years in space. Oberg's study looked at how much time the Voyagers would spend in interstellar dust clouds, which could gradually wear away at their surfaces. Dust impacts, even from tiny particles, can create small vaporized holes upon collision. Simulations of the Voyager's pass through these dust clouds show that Voyager 2's record is more likely to degrade due to its more chaotic orbit. The golden records could survive for over 5 billion years, mostly intact. But when the Milky Way eventually collides with Andromeda, the galactic merger might alter the Voyager's paths, posing new threats from high-energy cosmic rays and occasional molecules of hot gas. The Voyager's fates depend on how much dust the merger leaves behind. Should dust be scarce, they could survive trillions of years, possibly traveling across an alien universe.